Okay, so good morning, everybody. So today we are going to do a couple of things. The first one is, of course, talking about high fidelity prototype. That is the last step in fidelity, in increasing fidelity in prototypes. We have done like the low fidelity prototype with paper. You have seen medium fidelity prototype with Alberto last week. And you are going to do an exercise tomorrow on medium fidelity. And then the last part of the course will be mostly for you, for your project, related to the high fidelity prototype of your project and the usability testing. That will be the last topic, the next topic of the course after this class. So last step of prototype in fidelity, in which you have seen increase in fidelity under many senses from the paper prototype to this version here. So what is high fidelity prototype in a nutshell? High fidelity prototypes are computer applications. And so differently from the paper prototypes or the medium fidelity prototypes that may or may not be made with computers and with software applications, high fidelity prototype are. And they are also have some characteristics. They have a layout that is final looking, meaning sort of close or identical to the one of the final, let's say, product or the final things that you are going to create. And it has colors, it has graphics, it has icons, it has images, it has all the things that make it look close to a realistic or real application, a real system. You can do high fidelity prototypes in two ways mostly. One is using design prototyping tools, again like Figma, for instance. Figma can also be used to create high fidelity prototypes without code, or you can use real application code. Or you can mix the two, also in some particular cases. So in this course, we are going to ask you, since you are a computer engineer, to use real application code and not design prototyping tools for this stage, but they could be done also in the other way. So of course, high fidelity prototypes, since they are more realistic, close to realism in how they look, but also in how they work, they are much more expensive to build because you need to write code, you need to use things, you need to find resources, etc. Much more expensive, not only in a money-related perspective, but also in a time, in an effort related perspective than medium fidelity and of course low fidelity that missed many of this thing. In high fidelity prototypes, more time is spent with graphic design than interaction design, because in theory, you have done interaction design already in the previous stage prototypes. So the interaction, how you interact with your prototype, what the person can do, which are the tasks, how well it's fitted for that task is already decided at a certain level. So now the effort is how we can make this look real, realistic, and functioning up to a certain level. And high fidelity prototypes, of course, when tested with people, when evaluated with people will mostly comment about colors, fonts, background, how nice it looks, how bad it looks, etc. Because this level of presentation communicate something that is finished, something that is ready to be used. So most of the comment, not all of them, but most of the comment will be around these items that were not present in the previous stage of prototypes. And indeed, we focus more on the other thing in the previous stage of prototypes and in evaluating those things in the previous stage, because here you have much more focus on other things that are, again, colors, fonts, layout, the polished interaction, the alignment of things, the precise text, etc. So I was saying that high fidelity prototypes can be done in two ways. One with tools. This is an example of high fidelity prototype done with a design tool. This is not Figma, this is Pencil, but you can realize something like this also with Figma. And also with code, but next slide for code. So if you look at this, there's a screenshot of course. If you look at this, you can recognize that this looks like a real, in this case, website. I would say maybe not finished yet because there are things like subtitles goes here that needs to be finished before classifying it as a complete high fidelity prototypes, but you have tools to do that, to have interaction between pages, to have animations, to have functions, etc. in a semi-interactive way in which you have a high fidelity in behavior and high fidelity in appearance. So this is one way of doing. The other way of doing, that is again the one we are doing in the course, is using code. And I'm bringing here 3 examples of projects made in the past editions of this course, so that you have an example how should be a high fidelity prototype in code. So the first one is something we already have seen, just a different level of prototyping. Do you remember this? What is this? Matilo 2. Yes, yeah, we have met it in paper prototype level. This is the high fidelity version of that same prototype. So if you compare it with paper prototype, if you want to, you notice that there are elements that are still there. Of course, the basic idea is still there. The goal of the tool, that is enabling teacher in class with children to learn and play and do addition, subtraction, etc. With so around mathematics in class is still there. And then there are things that in the paper prototype were missing because of course they went through a similar process of what you went through. So they had heuristic evaluation, they had a mid-fidelity prototype, etc. And so changes were possible. And this also is one of the 2 prototypes they selected. They have 2 prototypes in paper and they selected this one. That is again the same we have shown in the paper prototype phase. So first question, does it look real and finished and ready to be used in class or not from this screenshot? Yes. So that's the first thing to check, right? So it is in this case, it should, because it's an high fidelity prototype, should have this feeling of something done. Then what do you think are the things that are limited or not really working here? Just by looking at them. Or imagining you have to do something like this. You will implement everything with high quantity of information everywhere, or there are things that are limited or not 100% working, etc. So this is the screen for editing objects, in which you can edit the object on screen. So of course there are just 2 objects because there are only 2 objects on screen. But yes, if we go in the catalog, that is here, we cannot go. But if we went in the catalog, there were not 2 objects, but like probably 5. So limited number of elements to be used. 3, 5, 10 elements to make the point, to prove that the 3 tasks are doable and the idea is reasonable and can be used. So yes, with respect to a finished product, something to use in the classroom, to give to the teachers and say, go with it, the number of items in the catalog is more limited. Then, what else? The GUI was designed this way for be more appealing for their children. So
some text is not in the middle, it's not like Safari is in the middle, but example is not, it is not like on the middle of the row.
that's another question. Like, my question is, which are the things not implemented, not which are the issues in this screen to you? The GUI is implemented. Then there are issues like example not aligned properly and Safari aligned centered, but this is small things. I'm asking you, like which are the limitations? Because centering a text is easy, could be done in 3 seconds. It's not a matter of complication for high fidelity prototype. But what do you think are the things that here are limited or missing or not working entirely?
The position of an object that you have maybe.
What do you mean for the position of an object?
Which part of the screen has an object? Maybe you can.
No, you can put it anywhere on the view screen, let's say, but there is a limitation around there. So these objects are expected to be on a flat surface and anchored in that flat surface. But this is quite hard in augmented reality. So actually, if they pointed to a surface, they will stay on the surface. But if they're pointing on the ceiling, they will stay in midair. And this is a limitation that is acceptable for an high fidelity prototype because it's a prototype. And of course, the group has full control on this kind of thing because in the demonstration phase or in the evaluation phase, they can say or they can do like pointing to a table and not pointing to the ceiling so that it can looks like and behave like properly done. Do you think they did the 3D models by hand? No. They found it on the internet and they use it, the 3 models. They are not complicated models like an apple. It's not something strange you cannot find on the internet and you can use it inside of it. What else? Look at the colors. So this is the edge screen. You can change the colors of the apple. Again, similarly to the catalog, there are just 3 colors to choose to choose from. One red, one green, and one yellow. So not pick your own color. Maybe in a final product it would be better to have multiple colors, but here to make it a point, just 3 colors. Could have been 2. What else? Look at save. Do you think that the saving in a persistent way is implemented or not? Like I create this scenario with this apple and the giraffe, and then I can save it so that when I close the application, I can refound everything I just created or not? Who say yes? Who say no? The answer is yes. And this is something also that will be written in the assignment 5. So some level of persistency must be present. Why? Because you are going to, so you do a prototype to test it, to evaluate it, to understand if still something is not working and how to improve it. So you want to have these people try your application. And if you don't have persistency and people makes an error, the application crashes, whatever happens, you maybe have spent half an hour doing the evaluation with a person and then everything crashed or there is an error or something happens. And if you don't have persistency, you just lose half an hour of work. And then if you are testing it with 5 people, and this is person number 3, you have to say, well, thank you very much for your time, go away, and you have to find another person because that evaluation is incomplete and you cannot redo it because the person has seen already half an hour of the application, so the person already has knowledge on how the application goes, it cannot restart it. because the information they will provide will be different. And then if there is no persistency, if there is no saving step by step or at a certain point, he will have to start from the beginning, everything else again. So yes, some persistency is typically needed and is required for assignment 5. So a database at minimum somewhere that saved. So when you create something, this something should be retrieved, and if you delete something, this thing should be deleted, etc. This level of persistency, at least they create, delete, update, and read the CRUD operation, basically, if your application, again, supports the 4 of them. Okay, so this was a tablet application. How do you think they created it with like technology?
Unity.
You say Unity. JavaScript is a little bit vague. React. Anybody else? So this was mixed between a React Native and a Swift application, with components like the 3D parts imported by Unity or others, but was a sort of native application. The group decided to go through that route, and was done with Swift because they only have an iPad, and they actually put it on an iPad to try it. So since they have an iPad only, they have to do it with Apple technology. And in this case, a React Native, plus libraries for handling the augmented reality part. Okay, example number 2. Again, a course of project a few years ago. This was for learning and reviewing sign language. I would say English sign language. So they have various tasks, various activities, and like here where you can learn how to sign a single letter, A, B, C, D, etc. And then there are exercises in which you see how things are signed, like Africa, the word Africa. And then there was also exercise in which the system tells you sign a word, dog, and there's also a picture of a dog, of course. And then the system see how you are signing that word and tell you, well done, not well done, 5 points, you lose point, etc. And then you proceed with levels, exercise, scores, etc. So this is a web application. And was done with React, in this case, as a desktop web application. Again, same question as of the other time, of the last slide. Which are the things that are limited in number, or not created by the group, or not working? The recognition is limited or not working? The recognition here is not working. So whatever the person sign, even if they wave in front of the camera, so there is a camera, the cameras turn on, and the person is depicted, so you can see in real time what's going on. So from that perspective, it's realistic. But then the difficult part, it was recognizing the actual signs. That's not done because it's hugely difficult and probably not even totally solved. With the specific sign language. So how they worked? They worked that the first time they did always wrong, and the second time they always did right. So the group figured out a logic to experiment the various cases. Like that could be first time wrong, second time right, could be vice versa, could be the dog exercise is always right and the Apple exercise is always wrong. So figure out a logic for exploring the different cases to make well done or not well done, to have also people then testing and evaluating this, understanding the various pathway, how to go on, how to recover from error, how to redo an exercise in this case, etc. What else? So this, of course, was not done. What else?
As a consequence of this part, probably the level of progress in the level doesn't.
This one? No, this worked actually, because it was like, if the log exercise is always well done, you will always get 5 points, and so at a certain point you will step up to the level. So this was not done because it's hugely difficult. So the difficult part are typically not done, but the easy one, like passing a level from level 3 to level 4, it's just an addition, and that's unlocking an element on the user interface, so that's sort of easier to done. Then what else? Do you think that they recorded the video with every science? No. They found it on YouTube. So this is an embedding of YouTube videos. They found some videos. And how many words do you think they have? How many exercises do you think they have in the application in total?
10.
Yeah, again, between 5 and 10 exercises, so limited number to make the point. And they also put all the letters with a video for all the letters. They could have also done less than this if they wanted, like maybe just the first 5 letters work and the other are present but are disabled, because it's always the same. You click on a letter, you see a video, and then you click another letter and then you see another video. So it's the same interaction. At a certain point you have 2, 3, 4, 5 examples, and then it's always the same thing. You don't have much to explore. And then, of course, this is just a screenshot. They have multiple exercises, and then there is something where you can see the points, etc. Okay, last one. This was another exercise, in this case, another prototype, in this case, a mobile application, on how to do physical exercise in a proper way. So also in this case, they have, well, I think you select some questionnaire, you fill out some questionnaire, and then there is a list of exercise you can do. And then when you click on one of them, let's say it's squat, you have a augmented reality video, augmented reality, let's say, thing that show you how to do the exercise. And then after you've seen the tutorial, you have to do the exercise on your own. And the application tells you if it's correct or not, and where is wrong, what you're doing wrong. It's your back that is wrong, is your arm that is wrong, it's the position, something like that. So again, same question as past time. What is limited here? And what is not working? The detection of the exercise is not working. So again, they did something again. The first time it was wrong for the squat exercise, and the second time it was right. And for another exercise it was always right, and for a third exercise was like always wrong. So they explored various cases because the interface, the application has different behavior according to the case in which you are. And then there is an additional feature that was you can re-watch what you have done. So like it's a live recording of your operation, and then you can press play and re-watch what you have done. And also this was preset. So they recorded some videos at home, a couple of videos, and then link them always to the play button. So a couple of one for squat, one for another exercise, and when you press play, you see one of those videos that you were pre-recorded. So not live recording, saving of the videos, but video already existent. What about other things that are, so, and then this is a picture from, this was a a colleague of yours of 2 years ago, with the face ID. And you see, since the group know how the application work, they put themselves rightly to receive an error on the back. So they made it wrong because they know that in that moment the application would have said that it's wrong and that the error is on the back. So they put them in the right position to do the right things for demonstration purpose, because they have control of the prototype. Again, this is a prototype, not a final version. What other things that are limited?
The AR models.
The ER models are not created by hand. They use, it's also written here in the slides, they use this website that is mywebar.com that allow you to import 3D models and give you something like this already working with no code basically, or limited code. And this is fine, this is okay in this case because this was just a tutorial. So you in augmented reality can see the movement, but it's like a video. It's not that you can interact, it's not that you can move the object, move things, you can just see things going on, how the exercise is performed. So in this case was fine. Of course, this is much more complicated. They cannot have done like the others because these are not videos, these are objects that you can change color and then they should preserve that color. You can change position on the screen and they should preserve the position on the table. And if you add another apple, and they should remain. So this is much more complicated in augmented reality to be done than this, that was instead more like a AR video in which you see something happen on screen, but you have no interaction with that. Other things limited.
The number of exercises.
The number of exercise. Here you can see 2 of them with this filter, but again, in total, probably there were like 10. Because doing an exercise, again, proving the point, it's enough to have a limited set of items.
Maybe the filters don't work.
No, the filter works. Yeah, again, the simpler things work because it's quite easy to do filter. The complicated things, so recognizing the skeleton and the position and if the exercise is properly done or not, that is not done because it's a prototype and it's complicated. Okay? So these are 3 examples. And this was done this is a mobile application. So how was done it? To you? Kotlin, Swift, Kotlin. This was actually done in React because it's a prototype. It looks like a mobile application, but it's not. It cannot be also not a mobile application, a real mobile application. So it depends on the skill of the group. It depends on what you need to do. Like handling. That year, we knew that handling, for instance, augmented reality with web technology is a huge pain. It's way easier to handle it with native technology, right? Kotlin, etc. Because there are limited number of libraries that works properly for augmented reality like this. So it's easier to do it in native technology than with web technology. But for things like this or for things like this, you can simulate the behavior and appearance of mobile application with, for instance, web technology, React, Angular, whatever the group prefer to accomplish this. So in this case, it's a mobile application that is a web application that looks like and behaves like a mobile application. Okay, so these are options that you can have, you can consider. And indeed, let me open a parenthesis. Indeed, next Monday, what we're going to do in the exercise that we are doing in class is opening an empty document, and for each group, I will go to each group and ask what you want to do in high fidelity, and for instance, she will reply a mobile application with augmented reality, and I will provide you, if I know them, options on how to do that. So for instance, I can say a mobile application could be done in web technologies, React, Angular, whatever, and for the augmented reality part, you can use this library, or you can do it in React Native, or you can do it in Kotlin, or you can do it in Swift, or these are options, so that each group has a series of options to pick from. And this is something we're going to do on Monday for every group that is present in the room, of course, not for those who are not. So this could be a moment for you to think about, to have some direction on how to proceed implementing the things you have to implement. And after A4, where you decide, of course, which prototype you will continue with. Yes?
Regarding the last two high fidelity prototypes, it seems to me that they are quite complex to, someone greenlight these prototypes and then you go and try to build it to have an actual product, okay? But if you don't know from the start, generally speaking, what type of technology you are going to use, like for the sign language one, if you don't know from the start, if there is any technology that lets you identify the sign, what is the point of doing the high fidelity? If you maybe you go to high fidelity, then you go, no, we can't do it because there is no tech. We need to do it from scratch. Shouldn't we, check it before? Maybe have some idea.
So, well, it depends. So, within the course, of course, the answer is no, because we end here. We are not going to do a product. You are not going to do that. Also, this is real. I mean, it's not that this is a fake. Let's say in the out of school world. Again, it depends. If you want to go to the market immediately, then probably thinking about the feasibility of the solution at the beginning could be, so after the need finding, basically thinking about the whole feasibility of the solution could be a good thing. Like everything else here can be done except this one, but everything else can be. So you can decide, for instance, that your product in version 1 just have everything else and not this, or this is not automated, but you have a person that is telling you if it's right or not. So you can have options on how to implement that in a real world product. This is totally doable, and this is also quite doable actually. So this is the thing that is really complicated to be done. Recognizing sign language, also because sign language change between languages. But these are instead more doable. It's just out of the scope of the course, implementing a skeleton plus AI algorithm to do it properly. We are focusing on the interaction. So you can decide to find a subset of things to do a product. You can decide that you want to do it because it's doable, or you can decide that actually you want to focus on how to, that your product will be how to do this, and you maybe will spend 1 year in research and development to do this properly. That's another option, but this option and is linked with the feasibility and also looking for market competitors that we didn't cover here. But of course, checking if it's vaguely doable with current technology is something that one can keep in mind to make decisions for moving to a product. Okay. So what we can learn from high fidelity prototypes, these are 3 examples of high fidelity prototype we have seen. So of course you can learn about screen layout, much better than the previous 2 stages of prototyping. So if screen layout is clear, it's overwhelming, if there are too many things going on, if it's complicated, if people can find important elements, if feedback is appropriate, is too exaggerated, is too small, etc. If color, fonts, icons, etc. are well chosen, understandable, etc. I already said feedback, so if the user notice and respond to various feedback, because of course in the paper prototype every feedback is evident because you have someone putting a new piece of paper in front of the person. So every feedback, even the smallest one, is hugely visible. Here you have a more realistic feedback in which you have differences between the huge big feedback and the small lighting around the word. So are these noticeable? Are these adequate? Are these fast enough or these low, etc., etc. And then you can start reasoning about efficiency issues. Are controls big enough or too small or too big? Are too close together or are too far apart? The scrolling list is too long, and so you maybe need a filter, a search, etc., or other way to compensate for that. So it's give you the opportunity to think about more also realistic content, even if it's limited, more realistic in the kind of things you are going to see. So the title, how long is the title of an item? The description, how long is the description of an item? The exercise in the other example, if there are 10 or 100, will be the list the same? Maybe if they are always like 2, you maybe don't need filters, you don't need search because there are always 2. But if could be like 15 or more, then you probably need to add some filtering, some other things. And similarly, you may be in the paper prototype decided to have a picture and a title and 3 lines of description, and then doing it, you will realize that 3 lines of description are not enough. You need more, you need less, you need to rethink a little bit what you put there, given a more accurate content and layout and space in pixel on screen. So these are things that you can learn from doing interactive prototype and also evaluating interactive prototype. And there was a video that is not available, but I think if you click on the link here, so it is a suggested video, not something that we were going to play anyway. It's a video from the Apple design team, I think in 2018. They start with a joke. But basically is an example of an high fidelity prototype. In this case, for explaining new features of Swift various years ago. And the title was Prototyping, Fake It Till You Make It. That is partially related to the high fidelity prototype, but is partially related also to the entire prototyping process that we covered. And prototyping is a way also to have an idea, not like this one in the video, because it's about the best toast in San Francisco, so not really something you probably want to implement or to realize, but prototyping is a quick and easy way in general, as you probably now should be convinced, to generating and evaluating idea solutions in a quicker way than realizing a product and then discover that there is no need for that or there are huge problems and revert back for months of work. If you just go implement the final, let's say, product. So this is a suggested video. If you want to look at it at the beginning, at least, it's something nice you can do. And it's in English, so there is no problem for language for that. So some tools in general for interactive high fidelity prototype. Before we mentioned Pencil, but also Figma is a way to do interactive high fidelity prototype without code. And with code, there are multiple options because, of course, there are code. Here, there are just 6 things that could be helpful. And now let's see if you recognize some of them. So the first one. What is this? Now, what is the first one? React. What is used for? web development. It's a framework in JavaScript and TypeScript for web development. The second one. The second one down. It's native development in React. So you use the same language, components that you have in React, sort of. You use CSS to create native application. Mobile and desktop also application. The other one. Yes, it's an online distributed database in which you can read, update, and it's a set of services in which the main one is a sort of database, JSON-based, let's say, database. It's a tree-based database from Google. So this could be one tool to use for persistency if you don't want, if you're doing a web application, if you don't want to set up like an Express server with a database, etc., you can use something like that. It has APIs to use. Expo. Do you know what is Expo? For native application. It's a little bit vague.
Web application.
In which languages? So Expo is mostly used to kickstart in an easier way and to maintain also in an easier way React Native application. So you can create a React Native application with React Native, or you can create it with Expo that has a series of facilities additionally to React Native. But then you are going to write React Native code as well. Let's move on. ngrok.
So that it is reachable by other devices.
It's not really to host application. Well, at least not in the free tier. It hosts application.
Yeah, I think it redirects in some ways.
Doesn't host application. It's make your application that is running, that is hosted on your computer, but is hosted here, it's not hosted somewhere, accessible on the internet. It gives you a public HTTPS address, so that everybody that has this address in the world can access your local, let's say, web application that is running on your computer. So if your computer is shut down, you cannot reach the application. So it's a tunnel that gives you a public HTTPS interface to your computer. And Viro is actually, I don't know if you know what is Viro. It's a set of libraries for augmented reality, for the web mostly. So for React Native, for web-related technology, etc. Okay, and then much more on Monday, according to the specific projects. Okay, so to conclude, let me just talk quickly about one technique that is mostly applicable in high fidelity prototype, but it's still related to prototype. We are not going to do it, but just for you to know. So since we are talking about partially limited technology or not having technology, so let's say that we have that prototype on sign language in which we don't have the sign language algorithm ready, but we want to test it to see if the market is ready, to see if people will use it, or if there are problems. Instead of doing like the high fidelity prototype I mentioned there, that the first time is working and the second time is not working and it's always the same, we can fake it. We can fake the algorithm. And we can fake it using this technique that is called the Wizard of Oz. That is, again, for faking technology that are either new or not existent or cannot exist quickly, or for filling in missing functionality that maybe are too difficult or too long to implement. It may be possible, but will need either 6 months. So with this technique, we can evaluate, understand if things work before actually having to spend 6 months doing it. So what the name, so the name Wizard of Oz reminds you what? Hmm? A cartoon. There is also a movie, there is also a book, but originally it was a book. What is the Wizard? Who is? What's the story behind the Wizard of Oz? Just the person.
He's faking to be
Thank you. He is a normal person living in Oz, where there are magics, etc. And the Wizard of Oz is a man behind the curtain. So it uses special effects, it uses like fire and projection and complicated, let's say, mechanism to make, let's say, a play to looks like magic and fantastic, are doing very complicated things, but actually it's just a person behind the curtain pressing buttons and making all this happening. But the people from the outside see like fire and this huge head here projected and strange things. But again, behind the curtain there is a man just pressing buttons. So this is from the movie, old movie about the Wizard of Oz, about Oz. So what's the idea? The idea of these techniques taken basically from the movie. So if you want to test something that is complete with finalized interface, with algorithm, but without actually written the complicated part, you can use this technique that is also not in a movie, the mechanical Turk. I don't know if you know it, but we will go back. It's basically a specific technique to have a software simulation with a human in the loop to help. So basically the idea is this one. You have an application that works, but at a certain point, that application, instead of working with the logic of the application, the backend, and whatever, just as is an interface for a person somewhere that receiving the inputs from the interface will produce the right output. So this is good when, again, the technology is not ready, like for the sign language. How you can implement the Wizard of Oz. You can have an interface, and then when the person signs, instead of having buttons well done or wrong, randomly selected, you can have a person that knows sign language, see what's going on, like a teacher of sign language, and can press the button yes, right, or no, wrong, and so give the right feedback to the person. Because people, so while for technology is hard to do that, for people doing something is easy if they are trained and learn how to do that. So that could be a way to implement the technology without implementing. Just pick a person that is expert enough to give the to implement, to realize what the technology is doing in a realistic, quick way. So this is a technique often used to simulate future technology, and the wizard is typically hidden, like in the movie, so it's not visible to the participant, to the person using the technology. It's always revealed, however, at the end. So in any case, the fact that the piece of technology is fake, even just for ethical reason, should be revealed at the end to the participant, to the person that tried everything. So Wizard of Oz typically go, as I said, high fidelity prototype, sometimes also medium fidelity prototype, rarely down that street, because otherwise you don't have enough fidelity in realism to realize that. And how to implement that? Well, you have to create a part of the system that works, leave some hooks for an interface for the wizard, and then the wizard has a back office, has its own interface to give input, to provide answer to the other interface in the right moment, in the right place, in the right format, etc. And the wizard, of course, should have a rule of behavior for when to respond and how to respond and how fast it should respond according to the kind of technology that is involved. So sort of algorithm, but given to a person to follow with their own expertise, of course. The benefit of this, as of course, is faster and cheaper than doing the actual complicated work. You can create multiple variations of the interaction methods because it's actually instructing the person to do something slightly different. You can, of course, identify bugs and issues before committing like 6 months to implement the complicated part. And you can also envision applications that are difficult to build, like the sign language recognizer. And also playing the wizard, in some cases, some context, allow a better understanding of requirement needed for the algorithm to be developed. Because doing that, we'll see different inputs, we'll need to provide different output in different contexts, in different situations, and in some cases can generalize that in better requirements for then building the actual algorithm. The risk could be that it be over-optimistic, because with a person, typically everything works always, if the person is an expert in that domain. The wizard behaviors is also difficult because it should take into account any system limitation, any contextual limitation, any interface for limitation that you have. It should have emulate expected system response. Again, not too fast, not too slow, adequate timing, adequate answer. It cannot be super intelligent as a user interface because it's not realistic enough, etc. And most of the time, need at least two researchers, one playing or helping the wizard, and the other one actually running everything and take care of everything, that everything works, because you have another piece that is the back office that is connected to the actual system that is used to the person. So you have multiple steps in this chain. So to wrap up, so let me just show you this. Do you know what is this? This is called mechanical Turk. It's the first example. Well, it's a sort of wizard technique applied. It's a first example, let's say, of robots, in which this one is not a person. This one is a machine. This thing here is a machine that emulate a person body, and it's playing chess. And so you go, and this is closed. It's a table, but it's closed, like this one. And you go there and play chess, and this machine play chess with you, and sometimes the machine win with you. So where is the trick? This is quite old. So how can a robot like this win playing chess, let's say 200 years ago or 100 years ago? There is someone here. So there was a person there that moved cables, and the cable moved the automa, and then according to the table, the things that were moved, the play were going on in a direction or another. So here there was behind the table there's a person that was playing chess. So it's a sort of Wizard of Oz technique before the invention of Wizard of Oz technique, and this is called mechanical Turk. Is actually the name of this, and this is one first example of automa because it's actually made as a robot because it can move. It's mechanically done in that sense. So there are mechanisms here to move the various parts of the robot to play the game, etc., etc. So this is an example of Wizard of Oz before inventing the Wizard of Oz technique. So wrap up quickly. We have seen multiple level of prototypes. We have just done one iteration of each stage, in which you have like the low fidelity prototype, and when we have a structured technique, and then the medium fidelity prototype will skip, in this case, any evaluation technique, critique, but it can be done. Another, let's say, heuristic evaluation could be done on the medium fidelity technique, could be done a user evaluation on that, and then you add various steps. So here you add visual design in medium fidelity, in high fidelity you have usability details, etc. And then you can do some more complicated experiment like usability testing, or also controlled experiment on the high fidelity / final product, etc. And we did one iteration of each, but you can, in theory, quickly test on user, get feedback, and go back to the same level. So you can do a low fidelity prototype, do some evaluation on that, and then edit the low fidelity prototype before moving to the next stage. We just move on because it's like a 6-credit course and not 60. Otherwise, we maybe would have spent more time. But as he was saying, in the real world, you can do also multiple iteration on that, or you can skip some stages. You can move from the low fidelity to the high fidelity, skipping the medium, for instance. So it depends on the time you have, on the effort you have, on the expenses. In all senses, you can afford it for the process to reach the final product. Okay, so this is all about prototyping. This is actually the same picture we have at the beginning of the prototyping session where we talk about prototyping. So before concluding, do you have any question on this? No. Before concluding, let me do an overview of assignment 5 that will be out this week, and you will need to start working from next week.